buffering. When you're watching an online streaming movies, watching a TV show online, you may be experience some buffering when you are entertained at its peak, and sometimes the server crashes and maybe the server error, and you may be distraught about this. And this is the scenario we are dealing here. So, in this increasingly digital dependent age, the data centers become very important to the current scenarios, and from the e-commerce platform to streaming movies or streaming online. And so the data centers are the main backbone in this modern technology, and the cloud providers have to give the quality of service and SLA to keep up with the client's agreement. And in cloud, the cloud must be scalable and elastic. Scalable means about accommodating the higher the workload and dynamically scaling over the system and resources to that workload. And elastic in sense of making the dynamic changes adjustable for the cloud provider. And cloud resource monitoring. This is an essential for performance, because nowadays, in the coming slides, we are discussing about the CAG, NIGO, and Ganglia about the cloud resource monitoring, because currently it is an top-stick monitoring tools which enhances and gives the alert about the predictions about the network traffic and solve the issues. Yeah, what I told about the CAG and SABIX are the popular frameworks of monitoring the resource assessment and management. And our goal is to predict the CPU consumption in the DC in the sense data centers, the virtual machine, and we can similarly look up that weather prediction, like a CPU prediction. With the current historical data, we can produce a prediction model which predicts the CPU's current usage, and it will help the servers to make up with this. Here we propose an approach which involves three-stage approaches, and that's clustering and algorithm evaluation and representative models. And methodology part, the methodology provides a system that resolves the problem for predicting the CPU consumptions, and we can divide the system into three main modules: data set information, clustering algorithm, and machine learning toolbox. The current the technology which the dataset involves is GWA-G12 BitBrain dataset provides comprehensive VM performance. That's a BitBrain is a managed the hosting a big tech hosting service provider. It's a BitBrain, and this dataset includes 1,250 VMs instance, which contain about 4,000 amount of instances. And this is the description of the dataset that includes the parameters as timestamp, CPU cores, CPU capacity, and CPU usage in megahertz and the percentage, and memory usage, and this discrete and discrete. These are the etc. are the parameters that used in the dataset. And it's a screenshot which I took. It's available online and GWA G12 BitBrain. And for the current being, we are streamlining the same analysis process for the gaining the deep understanding about the VM behavior to mainly two metrics, and it will also reduce the complexity, that is CPU usage and memory usage, and each virtual machines in the dataset is uniquely represented by CPU and the memory usage statics, which specifically we calculate the two statistical measure, that's the mean of CPU usage and memory usage, and the standard deviation of CPU usage and memory usage, which wide denotes the VM representing, and we only use to parameters here, that's mean and standard deviation of CPU usage and memory usage. Clustering algorithm. The clustering, we are leading the clustering algorithm. The clustering in the dataset to widely manage the heterogeneous VM load. Heterogeneous in the sense we are dealing with the different types of workloads within the VM efficiently, and in this clustering process involves a combination of K-means algorithm and the elbow method to group the VM based on the similarities. This method helps to create a distinct cluster with unique characteristics. And it also identifies the cluster behavior on the unique characteristics like periodicity and usage percentage. Coming to the architecture here, as we see, the VM monitoring tool and vSphere. vSphere in the sense it connects the user or the client to the server directly. That's a vSphere. And the VM monitoring tool, that's the VM1, VM2 to the end. There are different types of VMs, and using the clustering techniques, that's the two parts, the K-means algorithm and elbow method, which clusterizes the every VMs, and with the different centroids, they are clustered in among the right side, different clusters up to the K clusters R0 to like cluster 0 to cluster K types of clusters with K types of centroids. It's a table which we categorized or clustered among the data set, and which we inferred that we have six, as we see, 6 clusters, and their CPU usage and RAM usage, as I said earlier. The parameters we will use only the CPU usage and RAM usage, and here we can see the minimum, average, and the maximum.
Please keep silence.
The clustering algorithm provides the centroid and the VMs that belongs to each cluster, which obtain the representative time series for each cluster. Here, for easy understanding, we are classifying or taking to the next slides only 1 and 2 and 3, no 6, only 3 clusters for the future predictions. You can see the size that varies 109, 639 and 26. That's different. That's minimum, average and maximum number of sites. It's based on size. Elbow method, it is used to give a graphical representation of K-means clustering, which always will be in a way of elbow, hands elbow, so it's called as elbow method. The two parameters, the RAM usage and CPU usage from the dataset. The dataset is consist of 7 to 8 parameters. But for the clusters, yes, the clusters. So first, the K-means clustering, we randomly select the clusters, and the algorithm says that using this K-means clusters, and the centroid is randomly selected, and we update the values. Like mainly it's the distance method, the root of x to minus x.
I asked about why you want to have selected 6.
6, that's the randomly selected. We are selecting the centroid randomly. We can include more clusters, and we will get more clarification about the prediction, or clarity in the prediction. And this is the result of the first K-means algorithm, and we can see that the cluster in the figure 1, the cluster 1 is in a medium size, which enhances the 70 to 50% of the periodicity and the CPU and RAM usage. That is CPU intensive use and the cycle, it is in cyclic pattern. And cluster 2 is which we take as a large, with less than 10% behavior, and it is underutilized. And cluster 6 we take as small, and the cluster 6 has also CPU usage below 2%, and the memory usage is 60 below 20%. So it is memory intensive, and but not CPU intensive. We currently infer from the clustering algorithm. And next part is about selecting a representative time series. Time series, in sense, we can take the time series is a kind of record we keep, the daily record. Let me give an analogy that it's a diary. We keep let's assume that the weather. We are using a weather prediction. If the time series for a weather prediction is that record you keep about the daily temperature variations, the climate humidity, and every other parameters of the weather, and currently infer from that time series. The representative time series meant about the total diary, the diary of a monthly average of the time series, and we get a representative time series of that month. That's it. That's about the time series and
Time
representative.
series of VM systems or
Yeah, VM systems. You will get that set as this.
this is the CPU utilizes the servers in the VM systems in the clustering.
These are VMs.
VM systems in the clustering. Servers are the system. VMs like virtual machine. Server are machines.
Individual machines. This is about 4,000. This Excel file is about 4,000, and that is 1,250 VMs that I see. It's about it's a current ASIET in available online, and maybe it's about characterizing randomly or. And after the clustering results, and we divide into three. That's closed VM and average the model for closed VM and average model, and the model for the concatenated time series. As the word suggests, it is the time series that we take from the closest is from the centroid of the cluster, and the average is about the average, which we get a new time series from the current scenario. And the concatenated is about combining the both closest and the concatenated. And the result we get from the distribution of CPU usage from a random selected VM cluster. The algorithm we used is a custom algorithm which gave a data input as the time series of the VMs and the models for prediction for clustering models, and result in the selected model as per cluster. So, clustering, we can categorize this. What we get from the clustering is this. We get the minimum and maximum usage. We can orchestration. We can add more VMs to the same task. And model, it's just a prediction model, and it doesn't allow for the orchestration, and other parts will be in the cloud provider. We can only give the data or predict the data. The algorithm suggests that the first initialization using the k-means algorithm, we cluster the VMs on the time series data, and for each cluster extract the three 3 time series. And within the each cluster, we train multiple models, as you see in the algorithm. And the best model will be selected based on their performance for cost, average, and concatenated time series. The estimated root mean square, which we see the second for loop, which we said estimate the RMSE error for all VMs in the C using the 3 trained models. We estimate the root mean square error for all VMs in the cluster and using the 3 trained models. And we evaluate and choose the best representative models from each cluster by considering the performance of the cost, average, and concatenated model. And else we return the best representative model. And next part is about the machine learning toolbox. And this is an enhancer which helps the MATLAB regression learner app, which is a software which helps to try out every models or the choose models. We can select, choose, train, access, and export the models using the MATLAB regression learner toolbox. And here we use the various machine learning algorithms to predict the CPU usages. You can see in the next slide. And the data set we divided into the training of 70% and validation of 50% and testing of 15% data. And the performance of each algorithm is evaluated using the RMSE and the R-squared. This will be the output of the MATLAB regression learner toolkit. And just see the highlighted version, the LR robust and ensemble the backtree and NN file layer. Basically, it's from a biggest or a largest service provider of a big brains, provided by big brains. It's available online. It's a screenshot of the data set. And for the cluster 1, as you see in here, the cluster 1, the LR robust model fits the closest VM and ensemble back. Tree works well in the average VM, and NN tri-layered is the best fit to the concatenated VM. The training times for the different model vary, with some models requiring longer train time due to the length of time series, and the fact is, this factor should be considered while selecting the best model. Coming to the performance evaluation, commonly used is the R-squared and MSE, which is the mean square error for evaluating the performance for a machine learning algorithm to predict the CPU consumption in the data centers in the virtual machine. And here we are using RMSE, that's the root mean square error, quantifies the average square difference between the actual and the predicted value. Here we can see that the equation, that's the root of yi is the actual data we expect, and y dash I, which is the predicted data. The difference is squared divided by the n, which is the summation of n, and the root of that current result is the root mean square error. And here is table 4 that summarizes the process of obtaining the representative ML model for the closest VM and the average VMs and concatenated VMs per cluster. That's basically the highlighted version of the data ROM. And the figure 4, which shows the real value of CPU usages that compared with the predicted value using the best trained models generated with the representative and closed average and concatenated VMs. And table 5 is a result of all these processes, that the estimated quadratic error from the VMs that obtain the average mean error for the whole cluster. And that's the final result, the distribution of the RMSE error in the cluster. We can infer from that result of the box plot of the cluster 1, cluster 2, cluster 6 distribution of RMSE error and handle that error. The related works is comparison. Comparison was not in the base paper, but I went online and I found some references and I kept that in the reference. And this is the comparison between the MSE, MAE, and R square that I obtained. As you can see, here we can infer that MSE is more. Overall result that shows that the MSE is more optimized and efficient for the current scenario in that reference paper, but we are using here is RMSE that is more efficient. Advantages: effective prediction of CPU consumption and the utilization of representative models of different VM clusters, use of RMSE as a metric for model selection, adaptation of varying workload changes in data center, consideration of training time for different models, and identification of the best model for each cluster based on statistical parameter. CPU consumption, that's the disadvantages. The CPU consumption for the primary source for the alert generation potentially neglected because the threshold kept is 50%, so the other critical data can be neglected. And the use of specific machine algorithm might not be most suitable for all data center scenarios. As you can see, may not be applicable for any data centers. And the evaluation of models is based on the historical data. That's the historical data in sense, the past data that we obtained from the past scenarios, and which may not be always account for the sudden and unexpected changes. The use of K-means clustering and the VM grouping, which might not be most optimal clustering. We can use another clustering model, but in the base paper we used the K-means clustering. Yes. K-means and elbow method. As a conclusion, the paper introduces a three-stage system of predicting CPU consumption data center virtual machines, and the feature-based clustering approaches facilitate the group of VMs with a similar behavior and optimal strength of system. And the approach streamlines the training process and minimizes the presentation that are contributed to improve resource utilization. The paper emphasizes the need of consider dynamic workload changes in the data centers and suggest future research direction and enhancing the adaptability. So these are the references I used, and the comparison which I kept here is from the sixth reference. And thank you. Thank you for your attention. I did that.